Welcome to my channel. World Scene News. Subscribe to my channel for news updates all around the world. In the world of engineering, some projects seem to defy reality. They push the boundaries of what we believe is possible, challenging not just technology, but imagination itself. The Metropolis Link was one such vision, a plan to build a vast multi-line metro system beneath a city infamous for its treacherous geology and dense historic core. The ambition was staggering: to weave a modern transit network through layers of history and unstable earth, right under the feet of millions. The goal was not just a new line, but an entire underground network, completed in months instead of decades. It was a race against time, against nature, and against the limits of human ingenuity. The city was suffocating. Gridlocked roads, toxic air, and stalled economic growth demanded a radical solution, and fast. Every day without progress meant more frustration, more pollution, and more lost opportunities. City leaders scoured the globe for a partner who could deliver the impossible. They met with experts, courted the world's top engineering firms, and pleaded for innovation. Yet from Europe to North America and Asia, the answer was the same: no one dared take on the challenge. The risks were too high, the obstacles too daunting, the project's demands, tunneling through unstable ground, dodging ancient foundations, and racing against an impossible deadline, were simply too much. Even the most seasoned engineers hesitated. The Metropolis Link became a legend, the project too big, too complex, too fast for anyone to attempt. It was whispered about in boardrooms and classrooms as the ultimate test of ambition. For years, the proposal gathered dust, a symbol of ambition outpacing ability. It became a cautionary tale, a reminder of the limits of even the boldest dreams. But where 27 nations saw a dead end, one saw a proving ground. A single country saw not just risk, but the chance to redefine what was possible. China looked at the blueprints and saw not a fantasy, but an opportunity. An opportunity to showcase their engineering prowess and rewrite the rules of urban transit. The impossible, they believed, was just a matter of perspective. With the right mindset, even the most daunting obstacles could be overcome. And so, the story began. A story of vision, courage, and the relentless pursuit of the extraordinary. Why did the world's best say no? What made this project so daunting that even the most experienced nations hesitated? The answer lay beneath the city's streets, where the true scale of the challenge was hidden from view. The geology was a nightmare: waterlogged clay, granite bedrock, and the constant threat of flooding or collapse. Every meter dug risked disaster, and the ground itself seemed to fight back. Standard practice called for years of surveys and slow, careful progress, impossible under the 6-month deadline. There was simply no time for mistakes or second chances. Financially, the risks were staggering. The cost of failure would be catastrophic, with billions on the line. Cost overruns seemed inevitable, and no government or investor wanted to gamble billions on a ticking clock. The fear of a half-finished, abandoned project loomed large. Logistically, the supply chain alone was a puzzle, one that required flawless coordination and planning. Thousands of tons of concrete had to be delivered and poured with precision, along with steel, machinery, and specialized equipment, all needed on site, on time, with no room for error. A single delay could throw the entire schedule into chaos. Experts from around the world agreed. One delay could doom the entire project. The stakes were simply too high. Then there was the human factor: tens of thousands of skilled workers, managed and housed in record time, all while maintaining safety. Coordinating such a workforce was a monumental task in itself. For Western nations with strict labor laws and safety standards, the challenge was insurmountable. The risk to worker, safety, and legal compliance was simply too great. The combination of geological, financial, logistical, and human obstacles created a perfect storm. No single nation could see a clear path forward. 27 countries, after careful review, walked away. Each concluded the risks far outweighed the potential rewards. The world's answer was a resounding no. The project was left waiting for someone bold enough to try the impossible. China's response was different. Where others saw risk, China saw a chance to lead. The project fit perfectly with China's national strategy: speed, scale, and technological self-reliance. With a single government directive, funding was secured and state-owned giants were mobilized. Decades of rapid infrastructure building had prepared China for this moment. Their engineers had already conquered every imaginable challenge. mountains, rivers, and megacities. The secret? Parallel processing design, procurement and construction all happening at once. Chinese teams thrived on real-time problem solving, adapting as they went. Risk was not something to be avoided but managed and overcome. With political will and industrial might aligned, China declared the project a national priority. The world watched as China set out to do what others thought impossible. The race was on. Once China gave the green light, the project shifted into overdrive, setting off a chain reaction of activity across the country. Within days, teams of surveyors and engineers were on site, deploying advanced radar and seismic sensors to map the complex underground maze beneath the city. Every inch of the terrain was scanned and analyzed, ensuring no surprises would slow the pace. A central command hub in Beijing coordinated every move, linking ministries, engineers, and factories in real time. This nerve center tracked progress, solved problems instantly, and kept everyone aligned on the mission. Dozens of tunnel boring machines were ordered, and factories nationwide switched to round-the-clock production of concrete segments and rails. Specialized equipment was assembled and shipped out at record speed. A just-in-time delivery network kept materials flowing, eliminating the need for massive storage in the crowded city. Every delivery was timed to the minute, keeping the supply chain lean and efficient. 50,000 workers, engineers, geologists, and laborers were mobilized in just 2 weeks, housed in temporary complexes on the city's edge. These camps became bustling mini-cities, complete with dining halls and medical facilities. Construction ran 24/7, with teams working in shifts to keep the project moving. The city never slept as lights blazed and machines roared through the night. The work was divided into dozens of segments, with multiple machines tunneling from different points at once. This parallel approach slashed timelines and maximized efficiency. Above-ground station construction began in parallel. A high-risk, high-reward strategy to compress a decade of work into just 6 months, pushing the limits of what was thought possible in urban engineering. The construction phase was a masterclass in speed and precision. China's custom smart tunnel boring machines, guided by AI, adapted instantly to changing ground conditions, minimizing delays and boosting safety. Logistics teams delivered precast tunnel segments with military precision, feeding the machines in a seamless underground assembly line. Station construction used a top-down method, building the roof first, restoring traffic above, then excavating below, minimizing disruption to city life. Real-time monitoring systems tracked ground movement, air quality, and structural strain, triggering instant alerts at the first sign of trouble. Every team, from engineers to machine operators, was linked by the central command hub, ensuring flawless coordination. Innovation and teamwork turned the impossible timeline into reality, 1 meter at a time. Safety was managed with data, not luck. The relentless pace never let up. The city's new arteries took shape beneath its feet. The Metropolis Link was no fluke. It was the product of China's metro-building juggernaut. By 2025, China's metro network spanned over 10,500 kilometers in more than 50 cities, dwarfing every other nation. New lines and extensions opened almost monthly, with cities like Guangzhou, Shenzhen, and Beijing leading the charge. This relentless pace created a vast ecosystem of expertise and innovation. Each project refined techniques, standardized processes, and built a highly skilled workforce. High-volume production drove down costs, making advanced technology affordable and available on demand. Global companies partnered with Chinese firms, drawn by the scale and speed of the market. When the Metropolis Link was green-lit, the machinery and materials were ready to roll. China's metro might was unmatched and growing. China's metros are more than fast. They're smart and green, fully automated. Driverless trains run on AI-optimized schedules, adjusting in real time to passenger flow. Predictive maintenance powered by sensors and AI keeps the system running smoothly and cuts costs. In stations, smart crowd management guides passengers to less crowded areas, ensuring safety and comfort. Trains use lightweight materials and regenerative braking, slashing energy use by up to 30%. New stations feature solar panels, natural lighting, and rainwater harvesting, all designed for sustainability. Construction materials are chosen for low environmental impact and recyclability. These innovations are part of China's push for carbon neutrality and cleaner cities. The Metropolis Link was built as a model for sustainable urban transport. China's fusion of automation, AI, and green tech is shaping the future of mobility. The Metropolis Link's 6-month sprint exposed a global divide in how big projects get done. In the West, public hearings, environmental reviews, and political negotiations can drag projects out for decades. China's state-led model cuts through red tape. Land is acquired by decree, and state-owned giants work together, not in competition. Centralized power means decisions are made fast, and resources are mobilized instantly. In the West, fragmented contracts and competing firms can slow progress and drive up costs. China's integrated approach delivers speed and scale, but with less public input and more concentrated authority. Each system has its trade-offs. The West values transparency and rights. China values rapid execution. The Metropolis Link is a case study in how different models yield radically different results. When speed is the priority, China's system is unmatched. The Metropolis Link is more than an engineering marvel. It's a lesson for the world's cities. Political will and long-term vision made the impossible possible. China's success came from decisive leadership, relentless innovation, and seamless coordination. Investing in technology and embracing new methods paid off in speed, safety, and quality. Scale and integration created a cycle of expertise and cost reduction. While China's model is unique, its principles, clear vision, tech adoption, and strategic teamwork offer a blueprint for others. As cities grow, the need for fast, sustainable transport is urgent. The Dragon has shown one path forward, and the world is watching.